Hello, in this occasion we want to solve this problem. A car is stopped at a traffic light. It travels along a straight road so that its distance from the light is given by x equal bt squared minus ct cubed, where b is 2.40 meters per second square and c is equal to 0.120 meters per second cube. The three questions are: A. Calculate the average velocity of the car for the time interval from t equals 0 to t equals 10 seconds. B. Calculate the instantaneous velocity of the car at t equals 0, t equals 5, and t equals 10 seconds. And C. How long after starting from rest is the car again at rest? So, we are gonna solve this problem like this. The first question we are gonna solve is the part number A. In order to solve this part, we have to remember the formula to calculate the average velocity of the car. So, by definition, the average velocity is given by this formula: delta x over or divided by delta t. We have to remember that delta x is the change in the position, and we have to remember too that delta t is the change in the time. So what we are gonna do is to evaluate the average velocity using the formula given by the problem. If we come back to the first page, we are gonna see that the formula given by the problem is this, right? I highlight this formula. So the formula is given by this expression that I highlight already, and the constants v and c are the ones that I am highlighting again. So what we do here is we use this formula. We evaluate the position at the time that we are asking. So, for example, if t is equal to 0, then x is equal to, using the formula, right? The formula is this green formula, so is bt minus c t squared, bt squared minus ct cubed. But we evaluate this formula when t is equal to 0. So what we do is we replace every number here. For example, b is 2.40 meters per second square. So b is, we are replacing b like 2.40 meters per second square, multiplying the time. But the time is 0 in this occasion because we are evaluating the position when t is equal to 0. So it's 0 seconds square. Okay, now minus c. But what is c? We come back here to the first page and we see that c is equal to 0.120 meters per second cube. So that's the number that we put into the formula here, 0.120 meters second cube. On this occasion is the time 0 seconds cube. Okay, we gotta remember that any number that we multiply by 0 is gonna be 0. So it doesn't matter if we have this here we have the second power and here we have the third power. It doesn't matter. Here we have 0 and every number multiplied by 0 is gonna be 0. The same here. This number multiplying 0 is gonna be 0. So what we have here is that this term is gonna be 0 and this term is gonna be 0 too. So what does that mean? So that means that when t is equal to 0 is equal to 0. Okay, and that's the position when t is equal to 0. We have to keep this term here because we are going to use it in the future in a little bit. What we do now is we evaluate the position when t is equal to 10. If t, for example, here t is if t is equal to 0. But now we do this. If t is equal to 10 seconds. Alright? What is the position when t is equal to 10 seconds? So what we do here is we do the same that we were doing, just using the same formula, but instead of replacing the time by 0, we replace the time by 10. So then we do this. X when t is equal to 10 seconds is equal to, okay, we remember that the formula is given by this expression b t squared minus c t cubed, that is equal to, remember, b is 2.40 meters per second squared, right? The time in this occasion is 10 seconds. So we replace 10 seconds here, 10 seconds squared. Okay, minus, we don't have enough space here to keep writing, so we go to the next line. This case is gonna be minus c, right? C, what is c? C is 0.120 meters per second cube, multiplying, in this case, 10.0 seconds cube, right? Okay, this is gonna be easy. So we have to be careful because with the units, for example, here, if we multiply, for example, 10 by the second power, Alright, it's gonna be 100. So here is gonna be 100 because we applied the power to the number. We apply the power to the unit as well. So 10 squared is 100, but second, this unit representing the time in this case is second. Second square is gonna be seconds squared. Alright, the same situation here. 10 cube, 10 raised to the cube power is gonna be 1,000. Alright, so this is gonna be 1,000. We do the same. We do the same with the unit. In this case, the unit representing the time is seconds, so second square. Alright, so here it doesn't matter, the numbers is just it's just math. We have to multiply 2 in this case, in this first part of the formula, 2.40 multiplying 100, right? So that is gonna be 240 meters, but remember that we were working, or we were playing with the units. So this second square in the denominator, is eliminated with this second square on the numerator. They eliminate each other as well because they are the same. Alright, one of those units it's on the numerator and the other one is in on the denominator, so they eliminate each other. The same situation here. 0.120 times 1,000, that is going to be 120 minus 120 in this case meters, but this second cube is going to be eliminated with the second cube as well because they are the same unit. Alright, so in this case we have only units of length left. So in this case the units we have left are meters, and that is we are looking for. So we are right. We do the math here that we have left here, so it's gonna be 240 120 meters. So this is the position when the time is equal to 10 seconds. meters. So with the result, we have 120 meters here, and what I'm gonna do is to highlight this number here. I'm gonna highlight this number here, we have the positions when t is equal to 0 and when t is equal to 10. Alright, so now we come back here to the problem. We come back here and we have to calculate the average velocity of the car for the time interval between t equals 0 and t equal 10. We use this formula here. This formula here, right here, this formula is the one we have to use to calculate this average velocity. So the average velocity is gonna be V average is equal delta x divided by delta t. Delta x is, in this case, x when t is equal to 10 seconds minus x when t is equal to 0 seconds, divided by the time, in this case is 10 seconds minus 0 seconds. This is by definition. This is nothing really new. This is the definition of average velocity. Is the difference between the positions, the time that we are evaluating those positions. So velocity, in this case the average velocity, is going to be, we remember that x when t is equal to 10 is 120 meters, and the position when x is equal to 0 is 0 meters, divided by 10 seconds minus 0 seconds. This is equal to 12 meters per second. So this is the average velocity. The average velocity is 12.0 meters per second, and this is the first result we are looking for. Now I'm gonna highlight this. This is the first result that we are looking for. What is the next? Okay, next we are gonna solve the part B of the problem. The part B says, we come back here to the first page, and it says calculate the instantaneous velocity of the car at t equals 0, t equals 5, and t equals 10 seconds. Okay, we gotta remember that we are using this formula. X is equal to b t squared minus c t cubed. But by definition, we are going to use this formula. V is the instantaneous velocity, but that instantaneous velocity is equal to the derivative of the position with respect to time, so the xt. Alright, so what we have to do is we have to derivate this equation with respect to time. So what we do here is derivative of x with respect to time is equal to derivative with respect to time of this equation, right? And this equation is b t squared minus c t cubed. So what we do here is, because b is constant and c is constant too, they are constant quantities, we don't have to derivate those quantities. We only derivate the quantities that are related with the time. In this case, it's just the time. So what we do here is this: we are gonna distribute the derivative. And sorry, my English is still crazy. I'm still learning English. That's why I have this strong accent. But anyways, I think that you understand me, right? And that's what matters. So we derivate this term, and we derivate this term as well. So what we do here is, because b is constant, it goes out of the derivative, right? So b derivative with respect to time of t squared minus c derivative of with respect to time of t cubed. Alright, so because these terms are constants, right? So this is gonna be equal to b. Okay, what is the derivative of t squared? Is 2t, right? Minus c. What is the derivative of t cubed? Is 3t squared. And we rewrite this equation like 2bt minus 3ct squared. So this is the velocity as a function of the time. Okay. I'm gonna highlight this, and this is the velocity as a function of the time. Alright. With this calculation done, the next step is to calculate the instantaneous velocity at the time that we are being asked. For example, t equal 0, t equal 5, and t equal 10. Let's go and do that. So the first step here is velocity when t is equal to 0. We use the formula, okay? b t minus bt squared minus I'm sorry, no, this is bt minus 2bt minus 3 ct square, right? This is the formula we derivated previously. So when t is equal 0, we know how we know what are b and c already, what they are, we know that, and we are evaluating the velocity, in this case the instantaneous velocity when t is equal to 0. So this is equal to what is b? B is 2.40, remember, right? If we remember this, we know that b is equal to 2.0 meters per second squared, and c is 0.120 meters per second cubed. So this 2 times b, but b is 2.40 meters per second squared, times the time, in this case the time is 0, minus 3 c 0.120 meters per second cube, and in this case time is 0 seconds square. Okay, and remember, whatever you have multiplying by 0 is going to be 0. The same case on the second term, whatever you have multiplying by 0 is going to be 0. So this term is 0 and this term is 0 as well, and the result in this case is going to be 0. So we have that v when t is equal 0 is equal to 0, and that is the instantaneous velocity in this case when t is equal to 0. So we do the same process to calculate the instantaneous velocity when t is equal to 5, but the difference is that in this case the velocity is not going to be 0, it's going to be a different number. Okay, so we do the same. V when t is equal to 5 seconds, we have here that this is equal to, using the same formula, 2bt minus 3ct squared and in this case we have 2.40 meters per second squared, multiplying by 5.0 seconds minus in this case is gonna be 0.120 meters per second cubed, multiplying by 5.0 seconds squared. So what is the first result? In this case the first result is okay, this is gonna be all this calculation is gonna be 15 meters per second. I have this done already, so what you have to do is only to do the math here. Okay, so this is gonna be V when t is equal to 5 seconds. This is gonna be equal to 15 meters per second squared. Sorry, meter per second. And we highlight this part of the equation. We highlight this. Alright, but the situation is this. If you multiply 2 by 2.40 by 5, that is gonna be 2 times 2.40 times 5, that is gonna be 24. Okay, that is gonna be 24. And some important thing about this equation here is you have to make sure that you are working the units in a correct way. So meters per second squared per second, right? So what you do here is that because you have on the numerator this second, this unit, and you have here second square, you eliminate this one with one of these as well. So you're gonna have meters per second. Alright, and the same situation on this second part. This is gonna be 3 times 0.120 times 5 squared in this case. Okay, 3 times 120 times 5 squared, and how much is 5 squared? Is 25. Okay, and that is all this calculation is 20. Sorry, is 9. All this 3 times 0.120 times 5, that is 9. Okay, in this case it's 5 squared, that is 25. And the same here. Here we have 25 because it's 5 squared, and here we have second squared. This is second squared, and this second square is eliminated with 1 second square here as well. So the result is meter per second, and 24 minus 9 is 15, and that's why the result is 15 meters per second. Okay, so we do the next part, calculating the instantaneous velocity when the time is equal to 10. So V when time is equal to 10 meters per second. It's the same process. The only thing is that we are instead of evaluating the time when t is equal to 5, we are evaluating the time when t is equal to 10. And here the result is going to be 12.0 meters per second as well. So it's the same process, absolutely the same. The only thing we are doing here is that we are evaluating the time when t is equal to 10. Okay, so now we are going to evaluate the part C of the problem. The part C is when or how long it's going to take until the car is arrested again. So that's the part C. How long after starting from rest is the car again arrest? So what we do here is this. We know that instantaneous velocity is v equal to 2b t minus 3ct squared, right? So what we have to do here is we have to calculate the time when the particle or the car in this case is at rest, when it's not moving at all. So we know that when v is equal to 0 at t equals 0. We know that already, okay? We know that v is equal 0 when t is equal 0. We know that because if we replace t equals 0 here, if we replace t equals 0 here, and we do the same here, any number that you have here and the same any number that you have here multiplying when t is equal 0, everything is going to be 0. So the velocity is going to be 0 if t is equal 0. Okay, that's what happens. So but we have to evaluate this equation twice because this equation is a second order equation in the time. We can, in another video, I will gonna talk about second order equations. So in this case we have v equal to bt minus 3ct squared, right? When is 0. Okay, so if this equation is 0, we have this equation like this: v 2bt minus 3ct equal to 0, because b is equal to 0. So what we do here is we take this term that is resting here, and it's gonna be adding on this side on the equation. What we do here is we clear the, in this case is t squared, we clear the variable we are looking for. Alright, so we move this term 3ct squared, we move it to this side of the equation, and what we are gonna get is this. Then we have 2bt is equal to 3ct squared, but this t is going to be eliminated with this t as well, and we will have 2b is equal to 3ct, and this term that is multiplying on this side on the equation is going to be dividing on this side of the equation. So what we have here is t equal to 2b divided by 3c, and that's the time when the car is at rest again. So what we have to do here finally is to replace the quantities on the formula, and we have t, well, we have t equal to 2v, but b is equal to 2.40 meters per second square, dividing 3 times 0.120 meters per second cube, and this is equal to 13.3 seconds. Then the time when the car is again rs is when t is equal to 13.3 seconds, and this is the result that we are looking for. Hopefully this problem helped you to understand something about linear movement of the particles in physics, and see you in a next video. Bye.